In this video, we are presenting our results for the VIS Contest 2011. In the first part, we show the advection of 100,000 particles within the dataset. The particles are color-coded with the region texture and show the distribution of the flow among the dataset over all given time steps. We used a random seeding strategy on the nodes of all parts in the dataset. In the second part, we used the same volume texture for advection, showing the flow transport in one slice of the dataset. Integrating this information in forward direction reveals channel blocking behavior and recirculation effects within the relative velocity frame. We can see significant differences in the complexity of the resulting patterns between the SAS compared to the DES and SST model. To emphasize local recirculation effects, we used another texture with a radial gradient starting from the inlet toward the outlet area. Outward moving flow becomes darker while inward moving portions brighter during ongoing integration. Note that similar Lagrangian structures appear in comparable integration-based measures. Here we show short-range FTLE over 20 time steps showing bright separation structures moving within the flow. Those are partially moving against the flow direction at the suction side of the blades. In addition, dark blue areas may indicate vortical areas by means of local minima of the FTLE field. In the next part, we illustrate the temporal development of the FTLE field over the complete time range starting at the first time step. Again, we can see significant differences in the developing turbulence among the first and last two simulation models. During integration, all models converge to detailed separation structures and large regions of low FTLE values in blocked channels. Finally, we are going to show geometric arc length of path lines seeded at the first step and integrated over the available time interval. Large blue areas of local minima in the resulting scalar field hint on particles remaining at a certain position for a longer time period. In this case, this correlates to vortex regions in the velocity field. Thank you for your attention.